Hi, everyone. My name is Marco. I'm Italian. I live here in Germany, but I do the talk in English because of personal preference. My nickname is Acramius. That's my battle name. And I work as an independent software consultant and for the Rove team, which is composed by many GitHub hardcore users. We're awesome, and we love the marquee tag. Okay. For those who don't know this is the definition of awesome. All right. I'm also active in the doctrine team. We'll build the ORM. So what you're going to see is basically experience that comes from patching around internal stuff in the doctrine ORM. And I also often work on Zend Framework 2 as a contributor. Have a bunch of projects under Acramius, which is also my Twitter and GitHub handle. There's just a bit of projects I'm working on. I mean, as if I didn't have enough stuff to do, but I do it for fun. Yeah, mainly I'm a contractor for Saturn. So I'm having fun with it. That's the point in it. Okay. I'm talking about the proxy pattern in PHP today. How many people know what a proxy is in object-oriented programming? Okay. How many people here have been using Doctrine ORM lately? Okay, it's basically the same people. Okay. So I hope you will see something interesting today. There's some basics I'm just covering up again. So what is a proxy? A proxy is basically an interface. It's something between us and something else. So this is basically copy-pasted from Wikipedia. But the concept is that it is something between us and what we call a real subject. So in networking, the proxy is a firewall. It is a proxy, a SOX proxy. In object-oriented programming, it is actually an object which stays between us and something we want to act on. So the concept is quite simple. So you see the deer, okay? And I'm actually going to say, no, it's fake. Let's check Testa. So the idea is that a proxy is an object that looks exactly like the object that we want to communicate with. So we will say that the proxy implements a real subject interface. A proxy can actually completely replace the real subject because of the Liskov substitution principle. So whenever you want to use an object, you don't know if it is a proxy or a real object. The idea is quite simple. This is basic object-oriented programming. So we have an interface, and then we have a proxy and a real subject, and they both implement the same interface, which means that when the client, a client object, a generic client object, consumes a subject interface, so we have a client which knows about the subject interface, we can also have the client consume either the real subject, which implements the subject interface, or we can just have a proxy replacing it. So what we have is a client here consuming the proxy. It looks exactly the same. Doesn't know the difference. So in PHP, we tend to simplify things a bit. We're also a bit lazy. So there's not that many interfaces. And we can say that a subject proxy extends the real subject. And that's mostly how we do it nowadays, especially with code generation. But we'll see that later on. So you still should use interfaces, really. So what? OK, this is basics of object-oriented programming. So we saw that the Liskov substitution principle can be used to replace an object, an implementation of an object with another. What can we actually do with these proxies? There's some definitions. There's some here. How many have read this book, actually? OK. More hands up next time, please. This is really important, as well as this one. There's some definitions also in here. How many did read this one? OK, even less. Okay. Read it. It's important. It's almost history of computer programming. And there's also a lot of confusion on the internet about what a proxy is. There's different definitions, different kind of usages, strange names. So I just simplified it and took the ones from the Gang of Four, which is the second book you saw. And I'm going to basically go over the simplest implementations of proxies. So the first one is the remote proxy. So what you have is an object that is in your local address space, and it looks exactly like, for example, a customer object. But in truth, what happens is that it is an object in a completely different part of your system. So maybe a different server, a different process. You don't know. Basically, it is something that interfaces to something remote. We have virtual proxy, which is a kind of proxy that allows lazy loading and allows us to work with very, very heavy objects. A protection proxy, which is basically what a firewall does. It is an object that stays. Oh, we lost Mike. No. OK. A protection proxy, which basically allows us to filter access to an API transparently. So exactly like a firewall, just in object-oriented programming. And a smart reference. Smart reference, which is a concept which is very useful in aspect-oriented programming, event management, and so on, because it allows us to do logic when stuff happens. So what? OK. Fancy terms. And a lot of confusion so far, because we don't know what we can do with this. So let's get more practical and see how we actually implement those in PHP. Let's see the remote proxy. I'm going to go in order. So what we have is just a real subject. Then I just picture here the intertubes, internet. And then we have a proxy object. What happens is that we have an object that looks exactly like this one, but instead it consumes a client. This is basically a remote adapter, which communicates with a server component, which has access then to the real data. So that may be, if you're unlucky, SAP, OK? But basically, it can be anything. So you basically have this object communicating through these adapters and retrieving the data you want to work with. Let's make a simple example with a tweet. We have a tweet object. And this tweet object is very simple, testable. It's rather simple to use, instantiate, and so on. So the tweet gets instantiated with a data array. Data array gets stored locally. And then when we call the getText method, that method basically retrieves us a key in the data array of this object. We don't want to retrieve 1,000 tweets every time, especially if we want to just have a list of identifiers of tweets. So what we can do is implementing a proxy around it. Proxy, which is a second object, a tweet proxy, which extends the tweet. That's very important. That's what allows the Liskov substitution principle to work. And what we do is changing the constructor, because, well, you have to do the assumption that the constructor is not part of the interface. But constructors being part of the interface is an anti-pattern anyway. So don't do that. And we pass in an API object, an identifier of the tweet. And then the getText is completely different, but communicates in the same way. So when we call getTweetText, when we call getTweet, the API object is asked for a tweet text for this ID, and the data is fetched through the internet, basically. That's very useful if you, for example, want to load videos and so on, because you don't want to store all the videos locally in memory. You just want to fetch them from YouTube if you're doing some really nasty stuff, and basically load them on demand. How to use that? So the normal tweet just gets instantiated with the data, and then you can call it right away. Then for the proxy, you have to build some kind of Twitter API here. I don't know what it is, library of preference. And then I'm building a tweet proxy and passing in the API object, an identifier, and then I can call getTweet. So that's pretty straightforward. So there's some pros and cons about this. The first one is that you can share object across multiple systems. It may be a pros, it may be a cons, because it's really hard to keep data consistency, but nowadays we're really moving towards API-driven architectures. And it is really important to build smaller atomic systems that do smaller tasks and communicate with each other through APIs, through remote APIs. You don't have memory usage locally. That's really relevant if you want to fetch a YouTube video and you don't have it on your drive or whatever, big images. And it can work as an adapter for a completely different object somewhere. So if you have bad luck and you have to work with SAP, which is my unlucky example of choice, you just have the choice of building a remote object, basing it on some SOAP communication channel, and then you can basically build your object in your local space with the interface you want. Use the real data with the real object, use the remote data with the proxy object. And then you have a testable implementation, both for the remote API and from the local one, for the local one. So it is more complex to set up. It is not easy to set up. You need to basically design the proxy by hand. And obviously, it fails as soon as the adapter fails. The internet went out. Current went out somewhere on the other side of the planet. The other process crashed, and so on. And it is slow, of course. So the other thing that proxies solve, and that we had already in this example, talking about YouTube videos, is lazy loading. Lazy loading is for very expensive objects, for example, database connections, file handlers, very large objects that need a lot of memory and that you don't need all the time. And for example, hashes, encryption, and so on. You don't want to compute a hash all the time. You may have the hash object there, and you compute it really just when needed, because a hash may be designed to take 1 second of computational power of your system. And this is a pattern. This is not a proxy. So we're seeing a proxy that solves this. And first, let's go to the actual example, what we code. I assume everybody has done something like this somewhere. Maybe when you were doing like DB operations. What I'm doing here is very similar to the tweet. What we have is a customer object. I'm building the customer object with a DB connection. Passing in the ID is the same as the remote object in this case. And what I do is calling an init method whenever I call public API on the object. So what happens is that my object gets initialized with data only at the first call to any of its public API methods. So that's useful to avoid a lot of input-output operations, but that's really nasty, because now we have a customer object which represents data about the customer. And what does the customer object have to do with the database? Does the customer know about the database? OK, so there's some problems. We now have logic, which is regarding instantiation logic, the instantiation problem, mixed with the logic of our own data. We have a dependency to a DB connection within the data object. That's like basically what active record style ORMs do, where you have to extend some super class object which knows everything about the database with some static magic or something like that. Really nasty stuff, in my opinion, at last. And it's not really nice to read. You now have all these methods with the init method in it, and you have to remember that you have to call the init method, and when you don't do that, something explodes and goes wild. it is harder to test. Now I have to mock a DB connection object to just test a user object, a customer object. So there's a solution to that, and it is basically splitting it into two objects. There's two solutions to this problem. One is the virtual proxy. Virtual proxy, which is basically a wrapper around a real instance of the subject. Again, we're calling this real subject. And then we have a ghost object. Ghost object, which is much more complicated and involves some serious magic. Let's go with the virtual proxy first. Virtual proxy is basically a wrapper, I said. So now I'm building an image object, which is a bit simpler. What I do is building this image object with the path to an image, and then I'm loading the image directly as a resource here. So this image is a resource. I'm actually not aware if the GD library loads it all in memory, but it should. And then I have a getSize method, and this getSize method simply calls, does some calls to get me the width and the height of my image. And this takes a lot of memory. For every image that I create, I basically load all the image in memory. What we do is creating a second object, which is an image virtual proxy, which extends against, again, the image. Extending or basically having the same type is very important, keep it in mind. What I do is rewriting the constructor, and what I'm doing is not loading the image directly, but keeping just the constructor parameters in memory. And what I do is implementing the init method in this object, and then here instantiating the real image. So now what we have is two classes. One is just here for the instantiation logic. So one has just this init method and overrides all the methods of the superclass. And the other one is just about the data. So now we test two kinds of logic, completely different, in a completely different way, and completely insulated problems. So this solves just one problem, the other one solves the other problem. And that's good. So what we get is a lot of improvement in memory consumption. So when we build an image proxy, I just made up some numbers here, okay? I don't have an example. What we do is basically building an image, building another image proxy, and the memory consumption stays pretty much the same, okay? There's just the overhead of the strings. And what happens is then that as soon as I call the image getSize methods, then the proxies actually need to initialize themselves, and you get the actual memory and input-output operations. So there's some pros and cons about this, but the first pros is that we now have a dedicated object which just solves the problem of initialization, and it doesn't get in the way of my actual logic that I tested before. It has a better performance impact. We now have input-output operations only on demand. It doesn't have that much overhead. We have just the overhead of a second object in memory, and we have the constructor parameters in memory. So we have to keep those. And it is quite simple to implement. You can write it yourself, and it is better looking than the previous logic. But it is not really optimal if you have like a table of items and you want to load them all and have all the data about all the objects. And of course, lazy loading means lazy failing, which means that when you load a set of 100 proxies and then one of the images is missing, you get an exception. I'm just calling getSize on an object, and I get an exception. That's strange. I wouldn't expect that. And there's a minor problem, which is that the real subject and the subject proxy are not the same object. So if you implement something like fluent interfaces, you will have a problem. So we will maybe have comparisons where two objects which represent the same object from a logical perspective are actually different. So the identity operation is broken. That's where the ghost object comes in. So the ghost object is basically the same as the virtual proxy. What it does is defining a copy of all the properties of the real instance, but all the properties are basically null. They're unavailable. And any access to any public API of the object causes initialization of the object. So what happens is that we don't have a wrapped instance anymore, so we can't break the object by, for example, implementing a fluent interface. This is what the doctrine proxies do, which is by design required to do so, because otherwise the ORM would explode, not understanding which object is the real one. And you can maybe check this library out to see how we actually do it, because it's fairly simple code. We just have a template on how to generate a proxy. Let's make a simplified example of a ghost object, and picking the image again. What happens is that, again, I'm just storing the path with the constructor. I now have another property, which is initialized equal false. And what I do in the init method is actually creating a new image. So I'm really calling a constructor. And then I'm copying, localizing all the properties in my current object. So now I don't have a second instance. This one gets garbage collected immediately, assuming that you don't do any static mess here. Okay, that's up to you being having a clean logic about instantiation. So this is very tricky, and this is not actually how we do it, but how we do it is like a dozen lines of code. They don't fit here, and it's quite a mess to explain, especially with the reflection API in the middle. So there's some pros and cons. The pros and cons are basically the same of the virtual proxy. What we get here is the fact that we have the real instance being actually the proxy. So we now don't call methods on a second instance, but we call parent logic. We call logic on the same instance. So the identity operations and the hash of the object, they stay the same. Again, it solves all the other problems of the virtual proxy and has always the same problems. It is a bit harder to implement, and the constructor logic has to be actually solved via reflection. And there's this minor advantage that we have less objects in memory. So if you went to the talk by Julian this morning, there's less chances that you have a memory leak in here. I think it was yesterday. So same advantages and disadvantages, same lazy failures, but it is actually much more safe to use, much harder to implement. The protection proxy, which is a quite simple proxy type, and it helps when you want to filter access to an API. So you have an API, you already wrote it, you already wrote your objects, your application, and now suddenly someone abuses some method call, and you want to defend against that call. It's like ram minus rf asterisk. Okay, you don't want people to call that, or particular people with certain roles. What happens is that you then build this decorator around the real subject, and you basically apply the same logic that we had before, and you add protection to the API. So what we do here is wrapping a real instance of the object. We are not lazy loading it again. Now the API object is actually the one passed to the proxy, which extends the API object. And what we do is overriding all the methods that we want to protect, then calling some protection logic, and then proxying the call to the wrapped object. So we have, again, the problems about identity and so on, but now we can stop people from calling more than they are allowed to. And that's useful when you want to separate the logic about role access control from actually the logic of your objects. So you now code your object and worry about limiting access after that. How you would use it. So what I'm doing here is building the API protection proxy with a real API passed in, and then I'm passing a limit of 50, which gets passed here as a private property. And then I'm calling this method in a loop, and someone is just going to puke and say, no, stop, I don't want you. So the advantage is that now you can code your API, your objects, your logic, and don't worry about access protection. That comes later on. The disadvantage is that now your objects are basically, your proxies are modifying the behavior of your object. So you may have an exception type that you don't expect, a protection exception. But that's acceptable because we are talking about security. So we are basically closing out another system. What happens to that system is not our problem. Our first problem is just defending our core logic. The smart reference is another proxy type that I wanted to talk about. And it is basically a method of applying more logic as soon as some methods are called. So it is basically a decorator. But the difference between the decorator and the proxy is mainly the fact that the proxy keeps the same API and the same behavior of the real subject. So it is good for aspect-oriented programming. Anyone here done any AOP? That's scary stuff. OK, nobody. Does anybody know what AOP is? OK, so if you don't know what AOP is, it is basically introducing aspects and logic that should be executed as soon as that happens. It's like adding rules to your code generally. When this is executed, also execute this one. So there's a couple of use cases. For example, caching. You have a very slow method, and you want that method to be called only once in a while. And then all the other method calls will be cached. Logging, triggering events, mocking. PHP unit mocks are basically smart references. They allow you to modify how the object works, but they still allow you to say, OK, let it execute the original logic. And AOP in general, that's a really interesting use case. You have to have a good use case for AOP, but it is a good use case for this kind of proxying. So a smart reference example. What happens is that we have a slow method. It takes 10, 20 seconds to compute. And then we don't have any changes for like an hour. What we're doing is, I'm using an annotation here. Don't kill me. This is basically just saying, OK, this method has to be cached 3,600 seconds. And let's do heavy stuff in the real object. I used an annotation. You can use config. You can do whatever you want. But basically, the idea that we want that method to be cached. What happens is that in a proxy object, we override the method. So we have an API caching proxy extends API. We pass in an API object and a cache. And our do heavy stuff method gets overridden and now tries to first check if a cached element is in memory. And if it is cached, it retrieves that. Otherwise, it calls the real method on the API and then stores it in the cache. So this is pretty much voodoo. This happens when you have these large frameworks that you configure and say, connect this with that. They generate kind of this stuff. And OK, so let's see how you implement a proxy in PHP, actually. Implementing a proxy in PHP. This is what I usually see as a poor CODER'S proxy implementation. Anyone use PHP magic here? OK, yeah. So what we do is basically using the magic __ call method, and we build a proxy that, in theory, is able to proxy anything. what happens is that we just have a wrapped object, some wrapped stuff here, and this wrapped stuff gets called via call user func array, which is some magic PHP trickery, and some arguments. So this usually works, but it breaks the list of substitution principle because it doesn't have the same API as my object. So don't do this. Don't ever do this. Proxying is hard. So let's see what happens when we do that. We have a bank account, and then we have a function pay with a bank account. I don't know what he will pay because I didn't add any parameters, but I assume he will pay. I hope so. And then we have our poor proxy, and we build it with some wrapped stuff, and then we have this call method. So what happens is that as soon as we build the poor proxy with a new bank account, and then we say pay with the account, something will explode. So this won't work. Okay? The API is not the same, therefore it will basically crash. Implementing a good generic proxy, first of all, you have to follow the Liskov substitution principle. Otherwise, Barbara Liskov will follow you in hell. No, she's actually rocking, and she's still doing talks. I wasn't expecting that. And it is not so trivial to implement a proxy because PHP is a mess. Let's say it, PHP is actually a mess. So you have magic getters, magic setters, serialization logic. There's this serializable interface. There's sleep and wake up. What? There's cloning with the underscore clone. And there's public properties because we don't have property accessors, which is a feature that we tried to push some months ago, and which will basically get us rid of all the getters, setters altogether, but we don't have that because we don't have nice things. No, I'm just kidding. I mean, PHP is still good, but it's worse than anything else for this stuff, as far as I know. So there's a lot of thinking that you have to put into building a generic proxy. And also, what happens is that as soon as you start developing a proxying library, this is what comes out. So I don't know if you see this. Sorry. So this is basically the code that you have to write for a generic proxy with one getFoo method. All the rest is just dirt that you have to code in order to have the object behave exactly like the real object. So what we saw before are just simplified examples, obviously. This is the generic one, which does all the things. So that's why I wrote a library, which is called ProxyManager. It is used in Symfony framework and Zend framework too. And probably I am trying to push it into Doctrine, and it tries to solve all the proxying problems. Okay, you don't have to use it, because proxying is not a subject that interests everyone. Proxying is magic, and maybe you want magic, maybe you don't. Many don't, okay? But it still solves some use cases, so you may need to be aware of it. And it deals with the problem of bringing out the garbage and generating code yourself. You don't have to go wild and code your proxies by hand or something like that. So you now focus on the problems that you have and just say, OK, I want a virtual proxy, I want a remote proxy, I want a smart reference, and so on and so forth. So it solves a bit of problems. There's also the null objects, which is another thing. I can maybe answer that in questions later on. And that's how you use it, basically. This is generating a virtual proxy with ProxyManager. So what we have is my slow foo object, which is a very slow object. It takes 10 seconds to instantiate it. I've put just a sleep 10 seconds here in the constructor. And then we have just a doFoo method, which echoes something, OK? We assume here we're building something very large. Something very complex is happening here, OK? And this is how you solve it with the library approach. So you have some very ugly factory, because I'm not good at naming stuff, so that's what comes out. It's like the Spring's abstract singleton proxy factory, I think. I'm nearly there. I mean, I can do it. So then you say, OK, factory, build me a proxy. And I want a proxy of this type. This is the class of the proxy. And this is how you initialize that proxy. This is the init method of the proxy. So I'm passing in a closure that just says a proxy of wrapped object, set the wrapped object to the real instance, and then set the proxy as initialized. I can maybe show that as in an example, running and instantiating 1,000 of these 10-second taking objects. And then I can just call the API of the object, proxy do foo, and that's it. And that works, OK? So you don't have to code all this stuff. Somewhere it has been generated, it has been put into TMP or in memory, or it has used evil, OK? It is evil, but it has use cases, so I'm using evil in some cases. You can build smart references. So what you have is, again, a very, very, very ugly factory somewhere. And then you say, create me a proxy. And I want a proxy around a DB connection. I already have a DB connection. I want to build a proxy around it. And then I say, before each time you call the query object, then echo query is being executed. And after every time that you execute a query, basically call the query method, I want a query completed output. And then as soon as I call the bQuery, I get my output. So forgetting about the naming stuff, but that's much simpler than writing a 1,000 lines code class that solves the problem of proxying. And it integrates with Zend Framework 2 and Symfony 2. And it allows you, for example, to define services as lazy because you have this like giant security subsystem, for example, in Symfony. And it takes 10, 20 dependencies. And maybe you don't need it because your application is stepping out before. Same for Zend Framework. You maybe have an ORM and you're not even using it. A SOAP service which needs to parse some DSL somewhere. And you don't need it for every request. So what you say is you have some service and say, OK, pass it to the lazy service factory. She's going to instantiate it for me. And then you just say what it looks like. So you have the class name for the service. That's it. Same for Symfony. So you have a service like my service name, and it has a class. And then you say lazy true, and it will be instantiated lazily. Some useful libraries. There's a couple of interesting libraries that I went through while researching the different ways proxies were generated. Doctrine's proxy generator is basically my bootcamp. I got there, and there was already a proxy implementation, quite old one. And it was really simple to understand. It doesn't solve all the use cases, but it has a lot of them solved. And it works quite well, because I don't see that many bugs in the proxy implementation of Doctrine nowadays. There's my library, because I spent, I don't know how many hours on building it. It's just for fun, because I'm not using actually all the proxies that are in there. But I felt that I had to like cover them all and trying to build them and see what the edge cases of PHP are. And it really pushes the language to the limits, because you really do some very dirty stuff to get everything running. Flow by Typo3. And that's interesting because they use proxying for injecting dependencies. That is a thing that I saw and was quite interesting. So you basically have a class, like a controller, and you say, here, these are the properties, and inject like a database connection here, or inject a security layer here. And what happens is that Flow will regenerate the controller class and pass in and set the properties automatically. Positive, negative, don't know. but really interesting to see. And the CG library by Johannes Schmidt, who is very active in the Symfony community. And he has been building this code generation library that tried for the first time to abstract generating proxies. And that's where I got started at building my library, but I had to leave it because of licensing issues. So it's still a good example of very good abstracted code about how to generate code if you want to go that way. I mean, generating code is not for everyone. I would not suggest it to anyone, actually. But if you need to, just go there and look at how he built it, how he has done it. There's another interesting library. If you never did any aspect-oriented programming, take note of this. This is Go AOP PHP, which is a pure PHP implementation of the aspect-oriented programming paradigm, or some basics of it. I mean, there's not all of it in it, but the interesting stuff is that he uses proxies to add logic, like we saw in the caching example, caching a long-running object, a long-running method. And what he does is rewriting the autoloader of your application so that at runtime, while your application loads the object, it will generate the proxies around them. So that's really tricky. It's really magic stuff. And it's, again, an edge case, something that you may want to look into if you really want to see some real magic going on and stay there 3 hours and trying to understand what the hell is he doing here. I mean, have no idea what is going on. But very tricky, very interesting to see how it was implemented. OK, I'm just going to the trivia stuff. Proxying fluent interfaces. Everybody familiar with what a fluent interface is? Raise your hand. OK. OK, for those who didn't raise it, it's basically being able to call a method in multiple subsequent calls, chained calls, so-called, like jQuery. jQuery this, that, then, and so on. The problem is that basically it's calling API, and that API does some stuff and returns the object itself. And that breaks a lot of stuff. That breaks virtual proxies because we had a wrapped instance. So now we have an unwrapped instance. It breaks protection proxies, smart references. It breaks everything. OK? How many of you do use fluent interfaces? OK. Don't. How many like fluent interfaces? Go away. Out. No, seriously. Don't. There's no real meaning in a fluent interface, except for really some edge cases like building DSL. The problem is that you break the encapsulation of your object. This may be a bit controversial, but what happens is that you're returning an object with the same interface, but in the code that consumes that object, you're assuming that it is the same instance, while you just have to assume the type of the object that is returned. You can't do assumption of what instance will be returned. So that's my idea of why it breaks encapsulation. So we have this object. It's a bank account. We have a pay method, pass in an amount, and then we subtract that amount from the object and return this. How do we proxy this method without breaking the fluent interface? So when we do this, what we have is basically returning the bank account every time. So if we proxy this, every time that we call pay, we unwrap it. So you build 10, 14 wrappers around this object because you want to protect it, you want to cache it, and then with a single call, you broke them all in a single call. So there's a dirty hack to do that. And what you can do is something that I found quite interesting. It may be interesting for other use cases generally regarding wrappers, so not just for proxies. I extend the object, usual proxy stuff, and what I do is copying the properties in my local object. So I'm copying every property, private, protected, public properties, in my object by reference. Okay, very important, by reference. Which means that as soon as I modify the property in my current bank account proxy, it also gets modified in the bank account object. So now what happens is that I have the function pay, and I have some echo method, echo call before the actual logic. And then I can call parent pay, and what I get is something like this, paid 100, 200, 300. That's something really interesting. I found this the first time in the Zend Framework 2 dependency injection container because it was doing some of this trickery. It's dirty hacks. I hope it will help you someone in the future. And the other one is public properties proxying. So without the property accessors of which I was talking before, does anybody here know how I could call a method whenever I try to read or write from the name property here? What we can do is unsetting the properties while constructing my object. So I unset this name and unset this surname. What happens is that these basically are reference pointers in the PHP core, and when we do the unset, we reduce the ref counter by 1. The properties disappear because they're garbage collected immediately. And what we do is then wrapping the object. And what happens next is that now we can call the magic set and get methods. Because every time that you try to access the name property, PHP says, I don't know a name property in my object. OK, PHP is both completely ugly, sucky, it's shit. But sometimes it's really awesome. This is really nice sometimes. I mean, it's a dirty trick, and it doesn't work, for example, on HHVM, because HHVM was implemented differently. But it's still nice to know. So don't do this at home. This is an advice by Axel Saga, anyone who saw this. And that's it for me. So thank you.